This is a video on the trapezoidal rule. The question states, use the trapezoidal rule with n equals 6 to approximate the integral from 1 to 4 of x times the square root of 4 minus x dx. So let's start by drawing a picture that shows the trapezoids. So here's the graph of y equals x times the square root of 4 minus x. And we can see 6 trapezoids. Each of the trapezoids has base on the x-axis, and their tops are on the curve f of x equals x times the square root of 4 minus x. And we can see that the area bounded by the trapezoids is pretty close to the area bounded by the curves. Only this last trapezoid has a bit of an error. So now let's remember the trapezoidal rule formula. And it states that the integral from a to b of f of x dx is approximately equal to b minus a over 2n times f of x naught plus 2 times f of x1 plus 2 times f of x2, and then we keep adding 2 times f of the x values until we get to the very last one and we don't put the 2 on, just like the first one doesn't have a 2. So now let's look to see what we've got in terms of our integral. We have that the lower bound is a, which is 1, and the upper limit is b, which is 4. Also notice that if we take b minus a over n, we get 4 minus 1 over 6, and that's a half, and that's why the bases of each of these trapezoids are of length 1/2. So now we're going to plug in our numbers. So we have b minus a over 2 times n, or 4 minus 1 over 2 times 6. And then x naught is 1. That's the very left endpoint. So we have 1 times the square root of 4 minus 1. And then we start moving by 0.5s. That's the purpose of this delta x. So x1 is going to be 1.5. So we have 2 times 1.5 times the square root of 4 minus 1.5. And then we move from 1.5 to 2, and then we have 2 times 2 times the square root of 4 minus 2. And then we plug in 2.5 and 3 and 3.5. And then finally we plug in 4, and notice that we don't have the 2 in front here because in the formula there is no 2. So I worked that out on my calculator, and what I got was about 7.30 for my approximate area. Notice that our area of the trapezoids looks like it's a little less than the true area. And the true area, I used a calculator for, to 10 decimal places of accuracy, I get 7.62010, etc. And you can see 7.6 is not that far from 7.3. And I'm done with the problem.